and hopefully what you quickly notice is that we're continuing to use a lot of the same vocabulary terms and ideas that we reviewed in chapter 6. So transformations and congruence. We talked about things being congruent and similar before. I know I've used the word congruent a lot. We're going to continue to use it a lot and probably increase our use of it. So first off here, just a term when a transformation is applied to a figure and then another transformation is applied to the image. So then the result is a composition of transformations. What that just basically means is more than one thing. So maybe you reflect it and you translate it. Maybe you translate it and you rotate it. Maybe you rotate it and dilate it. So it's more than one transformation happening back to back. Okay, so check out this real world link in Braille, which I'm not sure how familiar you guys are with, but it consists of dots, small dots and big dots. Okay, and it says the letter R here has 4 large dots and then 2 smaller dots, and it asks you to circle the letter with the same shape as letter R. Which one has the same shape as letter R? You probably identified right away that it's W, okay? What transformation took place there for, it is the same shape. It's not it doesn't look exactly like R because it is a reflection. If I were to draw a line right here and reflect it over that line, it would be R and then W. So it is a reflection. Okay, over a vertical line. So, come over here. We're going to talk about things being congruent. Things are congruent if you don't change the size. So 3 of our transformations give us congruent figures. Translation, reflection, and rotation. Dilation isn't congruent because it changes the size. And remember, for congruent, it has to be the same size and the same shape, same size. So this is kind of a cool word. Isometry, same distance. So translation, reflections, and rotations are called isometries. Haha, I'm not sure if I'm saying that right, because the distance between each points are the same. Okay, so if I reflect, look, it's right here. Explain how these two are congruent, and as long as you can explain their congruence using translations, reflections, or rotations, then they are going to be congruent. Okay, so they talked about first you reflect it over a vertical line, and then you translate it down and to the right. All right, and then you have to give your translation notation right here where you talk about this one maps onto that one. We're going to be a little more specific about that in a minute, more like tomorrow. But let's go down here. So first, are they congruent? Are they congruent? And your answer, yes or no. Okay, if your answer is no, you are correct because it's this little jobby right here. And now, if that one would have been right here, we would have said, yep, just translate it, just reflect it over a line, and you're good to go. But because that is not in the right spot, it's not. If your answer is no, it's just no. You don't have to give any other reason.